Hi, I'm RC Jim, and in this video we're going to be having a look at our C-47. And in particular, we're looking at the landing gear. So, we've got our original landing gear over here on this side. Folds down like so, comes up this way. The servo can't hold it without the power on it. You know, it's got this little thing here to help sort of lock it in place, but it doesn't allow it to go far enough, and the servo just allows it to go down. So we're in the process. Oh, and the other thing with this, well, two other things with it: no suspension, so when it's locked down it can't move at all, and you got a big heavy plane. You know, it's already well over 4 kilos before I add any batteries to it and before I do any more painting and whatever, so it might end up being a 5-kilo airplane with no suspension except for whatever give the tires have. That's not good. The other issue is that these things we're tending to rub on the sides, and I've put some bushes in there, but you can't actually remove these wheels. They did all of this brazing and soldering or whatever they did here, putting the wheel in place with no way to take it out without busting it. So we've got a bit of an issue with regard to that. So we've come up with this one here, and this is our prototype, our first sort of attempt at doing it. I've got these little cylinders that compress. They got springs in there, so I've got one on each side for the vertical, and I've got one in the back, realizing when you land on a grass field, you know, you can have some forces going backwards, and I didn't want it ripping apart things in here. So I got full suspension on it, and as we look at it, we can get it all the way down, and we can get it all the way up. Okay, so that's where we're at. So let's just have a look at what was involved in coming up with this. Well, this is what we are aiming to duplicate. Well, maybe not duplicate, but have some sort of representation that looks similar to this. The actual C-47 landing gear. Pretty amazing. If you had a man standing next to that, that tire is, you know, not quite as tall as he is, but it's a mighty big wheel there. So anyway, we want to get something that looks somewhat similar to that. So as we began planning, we made some sketches and had some ideas, and we ended up with this as being something to try to do. So we've got these little cylinders that we can purchase that have the springs inside. We've got various clevises that we can attach to wire and bend the wire and so forth. And then later on we can put in the crisscross thingies using some tubing over the piano wire structural part of the gear, and make it look a little bit more scale-like if we want to. And that's optional, but certainly we can do that. Here we've got the strut going to the back, and again we would like the suspension not only to be vertical but also to allow some give going backwards. I find many times landing on the grass that it just, you know, hits hard enough that it really puts a big jolt going backwards on the landing gear, and so we want to be able to accommodate that. Okay, we're in the process of getting ready to make the landing gear. So we got this part that is the main part that swings down. The servo pushes on that, push it up and down. This bit will attach down here onto the little thing like that, and the axle will come across to the one on the other side. These will have springs in them, so they will go in and out. And so anyway, this is my sort of first attempt at one of these bottom units. Well, actually it's my first attempt on both, you know, getting that bent and the right length and all of that, as well as this. So just a couple of things that I came across. One, it's very important to keep things straight and whatever. So I wasn't paying too much attention to getting that exactly where it needed to be to have this slot right in the middle, which would have been nice. And in particular, I drilled this end here without thinking too much about where that was. So what I've had to do is rotate this top bit and put some new holes through there. The other issue that I had with this is that even though I did it in the drill press, I was drilling it with it in this thing here, and it was pretty easy for it to get misaligned, and so my holes aren't exactly in alignment. So what I've done for my hopefully the final ones is I've done all of the drilling with the tube all together. Even in attempting that, you know, some of these still aren't perfect, hence I've got more than 4 there. 1, 2, 3, 4. Those 4 there look pretty good. This one looks a little bit wonky on this axle hole on the end. I think the other ones are going to be quite acceptable. And actually that's not the axle hole, that's the hole for the pivot for this end here. And given that these things can rotate, you know, that's not a huge issue either. But nonetheless, we want to get them looking as good and precise as possible. So anyway, I've done it, drilled the holes with all of this in place. I've been careful to trim off the burrs off the bottom, you know, because when you set it on the plate for the drill press, that can make it go off a tiny bit. You know, marked them all out, and with a longer piece, it's a little bit more steady and, you know, positive as far as getting things located. So I've got all of the holes drilled for those. I've marked out where I'm going to cut them. I'm going to cut them, file them down. Once we have them done like that, they'll get cut off, and we will cut the slot in the end of it as you see on this one. We've got a little prototype thing set up here, and so we're now going to have a look at how it might perform. This is showing the back strut coming up here like this. That's this guy. And then this vertical bit is this part. It'll go like that. And this is going to come up and go up like that, and it needs to end up there. So I need some more clearance in that spot there. Not a big deal. Just on the one side is all that it's needed, and it's only a little bit that it's coming short, but we will clear that out, make sure that's going to be okay. It's got plenty of flexibility. This one's the one that's a bit wonky, and you can see it's got flexibility to go every which way, you know. That will be fixed down here with the axle. That'll be bolted, so that'll keep that steady, you know, straight and whatever. And then this is just free to do what it needs to do as it goes up and down. So I did think about maybe putting some thread locker in there, but I don't know that we really need that. Flexibility is good, so it can move however it needs to. So we've taken a rat tail file and we've filed that little bit there just on the one side. That allows this to be positioned as so. And so when the wheel is all the way down, it's right there. And as it comes up, it's got to follow this curve. Here it's pivoting with this guy here. Coming up this little light line there, which you may or may not see, but I'm just following that as it goes up. And yeah, up to there, and keep that in the center. So it can go just a little bit past where we're anticipating that it's going to end up. Okay, so we could file it a tiny bit more to give ourselves a little bit extra if we wanted to. But according to plan anyway, this is good to see. This curve here is what we're following. It's good to right there, so it's good for about 6 or 7 mils beyond what we're anticipating to be the up position. So that's going to work out well. As I cut these off, I do them one at a time. Clear the burrs out of the inside of it. You could file the outside of it too, but the critical bit is the inside. Just using a Stanley knife to get those burrs out of there so there's nothing to scrape on it going down in. Okay. And having done that, we take a punch and we give it a whack. Get it down close to where we think it needs to be. It's interesting, it bulges out on one side more than another. To get it off, I stick it in the vise, get on this with this wrench. So I then have a little piece of the cylinder where I shortened that up, and I've filed off the edges to give it a rounded sort of edge on there. And that's what I use to test to see if I'm getting reasonably okay, and it's looking pretty good. But given that the other one is tapered, and the more I drive it in there, the more it's going to widen out the outside bit. For the last bit, I just use this to get it in there. Try to keep it straight as I go. And get it however far I think I might need to be. You can see where there's a little dimple on it as to how far it's gone as compared to the hole that you're going to use to tie it together. And then of course we need our 50 millimeters for the distance along the way. So what I need to do is match up. Okay, looks like it's down to there, so that's farther than what it has to go. Right now this is going just beyond that. Well, if I look at this side I can see where it is. So it needs to go down at least to there where my thumbnail is, and yeah, that's lining up that hole with that. Okay, so we're okay there. And what we can do if we want is we can just snug it up a little bit for that part that was done a little bit wider than what it needed to be. Just give it a light tug like that to sort of flatten it out in there. That's nice and solid now. So this is just an old thing, so I can get this off with pliers. Okay, so that one's fine. So now I can cut this one off, and then I'll do the same with the other one. And the reason why you need to do it when they're all together is this thing has got to stick in that far, which would be beyond the end of that. You know, I could grind off the end of that thing that I've pointed it up there. But nonetheless, by having it all together, it gives me clearance for that. Okay, time for a bit of an update on our landing gear on the C-47 Dakota Skytrain. This is the old landing gear. It was in here like this. Had to break that to get the wheel off of it. And of course we had this strut coming up here like this onto the axle as well. So that went up there like that. So we're replacing that. Oh, and it had this lug at the back here that thing was hooked onto. Okay, so what we're replacing it with is this setup here. So in place of the brass lug at the back, we've got this little aluminium bit here that will bolt onto there. Then we've got this that we put together for the back sort of support. That will go in there, and it'll bolt through that hole there. And it'll go like that. That's going to come up to the axle. This is then going to replace that other thing there. And these will come up, the axle will go through the holes here. Okay, so those are going to come up like that, and that is basically going to be our landing gear. I will play around with the thought of putting some cross bracing in here, like on the actual Dakota. But I think in terms of structure, this is basically going to do the job. So in terms of things that we need to do, I've sanded back on this a little bit to give us a little bit more clearance for this guy. I've got to get a tiny bit more clearance for that guy to move over, and that's assuming I leave him down all the way. This one is a tiny bit higher, but I'll probably start out with it down lower, and I don't think that's going to be any big issue. Certainly in the up position, it'll be no difference at all, you know, tiny bit of difference that way. This way it's going to be back just a teensy tiny bit more, but we do have an adjustment for that. So anyway, that's a little bit of clearance for that. Then where we've put our control horn on here, we just soldered it onto this collar, and then got a little bit of a flat spot on the wire that grub screw goes up against. But I need a little bit more clearance for that down here. So it's going to go like that, and that I've filed it all the way down even with a collar down there. So in the up position, I might need to file it a tiny bit more for the up position, but not much. And then the down position, it's certainly fine, because that's only going to go down about that far. So we'll clear out a little bit of area there. Yeah, I think we'll depend on that to help locate it. It needs to move a tiny bit that way. So we will move over the edge of that just a little bit. And then I guess this over here is going to hold that end to keep from going too far. A lot of things of this project can seem quite simple, and yet they can be rather complicated. Right now what I'm needing to do is to relieve an area down in here for this collar and linkage arm. Get it standing up. Okay, so that's going to be a stop for it. So just marking on this old wood, you can't see a pencil line, so I stuck tape down, put a line on there, and then another piece of tape over there with a line. So right now I'm using the angle grinder, the big one. I had a look at the little one, but I can't get it in there to have the blade straight, so the big one is the one to use. And so I'll get that line done over there, and then I'll take it back and forth in the middle and clean it out to get enough clearance for that. Well, we're getting things in place here. So we've got our little support fastened back here with a screw through there. That's supporting this guy. Working on this, I've cut the slot in here to sort of hold this to keep the thing from going back and forth. But what I'm wondering about is whether or not that's hitting on the bottom. And it's kind of hard to tell. I'm looking at it to see whether it comes up when I go this way or not. And it all seems pretty consistent. But that still doesn't say it's not rubbing. So what I'm going to do, take a piece of paper, put it underneath that. And it should be that that is not hitting underneath that. And this should be easy to pull out. But no. It's hard to pull, and just get it on the very edge, and it's hard to pull there. So I think where it's hitting is on that edge. I'll just see if I can get something underneath here. That's, yeah, it's free underneath this side of the collar. So that other side there, I need to clean that a little bit. And what's happened is the grinder that I've put in there has been on a little bit of an angle going into that spot. So I'll take a file and just see if I can clean out a little bit of that inside there. I think the top part of the hole is fine, and it's the bottom part that is the issue. We'll see what we can do. Actually, this is normally used for metal, but you do what you can with what you've got. We had a crack going across here where the hole went in, and so I've put Gorilla Glue onto here. I've sort of worked it into the crack and put it into the holes, and there's some tiny bit cracks in other places as well. I then put tape over top of it to hold it all down, and that has forced the Gorilla Glue into those little crevices. I thought about using a CA adhesive, but with this old wood, I have not had good luck with it really gripping well on the old wood, whereas the Gorilla Glue has been better. Then I was getting a little bit of a interference from the side down here, so I had to clean that up a little bit more. But as I look at it now, it's still pretty tight over there, but I can sight down through this way and look, and I can see clearly there's nothing underneath it, and it's just rubbing against the side there. And I think that is going to do well to hold it in place, and in time it'll just tend to free up more anyway. And that's nice and centered, so that's going to be good. So now we'll put the straps across here, hook things up, and see how things are looking. I'll just have a look at the length of this. It looks pretty straight going that way. Just wanting to make sure that our lengths are equal coming out here. Yeah, that looks pretty good. So I'm going to tape those things in place as well, since I figure that's a pretty good length to get started with. So now we need to work out the length for this guy. Okay. So this is a bit tight. That will go in there once I free it up a bit. Okay, that's definitely hitting on here now. So we'll give it about that same sort of length on this side. A bit more maybe. Okay, so that's going to be the length of our rod. Okay, so here we've got the new assembly. There's the old one. We've got the foot down here. It's interesting that that could turn a little bit. We might do something to make sure that that stays put. A little bit of glue or something along the sides just to hold it straight. But anyway, don't have the things holding on here, because what I was doing first off, this would only come down a certain distance. I had cleared out a little bit here and there, so it wasn't hitting that. And I wasn't sure whether it was on the bending of this, as seeing how far that could go. But anyway, it was stopping about up here. And so I took loose this, and I was then feeling on the shaft here as I set it down to see if that would lift up. And it was lifting up. So I realized what I needed to do was to clear out a bit in here and in there where the arms are coming down to give that clearance. So now we've got it to where it sets right down on this leading edge piece of balsa here. And so with that, when they're up compared to what we had before, okay, when they're up, we've got them, say from the wing to the axle is about 140, and here from the wing to the axle is about 137, something like that. So it's just a tiny bit farther up in the air. And when they're down, they go all the way down to there. This would only go down to here, so down just a couple of millimeters lower. And of course on the real plane, that's how they set, you know, that way. If it wasn't for that leading edge, we could go down further, but that leading edge is structural. You know, it's a load gets on the wing pushing back here, and it needs that leading edge. So I'm very pleased with that. And I think as a prototype, it's not only going to be a prototype, but I think that's going to be the final one for this side, and then we'll just make one like it for the other side. Still have to test with the servo, so we'll fasten this down here with the little saddle bits and hook up the servo, and we'll see how that works before we progress any further. Okay, we've got the landing gear in place, so it goes up and down. I now need to work out, I've already done this on a drawing, but I want to verify it on the model. I want to work out what sort of travel we need. And I believe it's going to be about 26 millimeters, so that's on 26 right there. So this thing should come up to where the hole is on the end. And that's pretty well exactly where it is. So I need 26 millimeters of travel on the servo. So let's now look at the servo. Okay, this is the servo that came with it. And ideally, what I'd like is for this to be close to a locked position. If I can get this up here. When we got it all the way to the back, I would like this thing to be pretty well locked. So someplace back in here maybe. So this thing pulling on it this way, it's going to be really hard to move that as compared to when it's perpendicular. And then we can adjust this depending on how much travel we get out of it. Okay, let's use something to just guide it along here. And we want 26 millimeters. Okay, so let me get this straight and see if I can hold it straight. So that's in the middle. And we got about 29. Okay, so I can go farther back. In this back position, it will be when the gear are down. So that's where I want it to be the strongest. That's where they're really going to get knocked around. Okay, I got a guide. Nice rusty landing gear. Okay, put it up against the guide. Try to keep things straight. I think we can go all the way into the locked position, huh? I did put this ball thing on here to get it out to where it could go straight across the middle if need be. And it looks like that's what we're going to be able to do, which is ideal. Okay. And if this is still too much, we could move in a notch, but we will see how we go. That's about right. Very close. Maybe a smidgen, 1/4 of a millimeter less than what we want, but pretty good. Okay, so it's all together. Big issue right now is it's got too much slop. Just the way it is attached down here. The servo is moving a tiny bit when I move that back and forth. I'm not sure if that's just the arm or what. I'll have to look into that on the servo end. But it doesn't take much of a movement down here to allow movement there. But apart from that, it does what we need it to do. So, two things. I'll be checking what's moving on the servo down there, allowing that slop. But then secondly, I might put a rod up this way to do similar to what the old one had, where it can't go farther than where it's there. Yeah, the other thing that we could do is this aluminum tube could come farther down to support it on the back side. No, I can't do it on the back side. Do it on the front side. Okay, the square aluminum tube could extend down this way and hit against there. That'd be a neater fix, wouldn't it? I was having a look at why it was that I was getting movement on the servo, you know, when I was wiggling this thing back and forth. Yeah, in particular, you know, that link going back and forth that way. So anyway, I pulled it apart and I noticed that there was movement where it was joined onto the mounts. And so I actually debated about pulling out the rubber things out of there. As I was doing that, I saw that they're a bit loose. I thought, well, we'll take it off anyway and have a look. And what I found in there was this plate mounted on the thing that it goes onto there. It didn't have all the holes in it, but just that solid plate. And you got these skinny little arms coming up there, and then this huge plate that's glued onto the panel there. So I thought, that's ridiculous. Let's get rid of some of that material and reduce the weight a little bit, because it's pretty hefty for just a couple little mounts. And with all of that area and just two little things, it didn't need so much. So I started drilling on it. And I got thinking as I was drilling, you know, heat will release epoxy. It'll melt it, and the epoxy will let go. And sure enough, as I was going along, getting towards the end of it, I saw one end was coming up a bit. So I took my heat gun, put one of these tabs in the vise, and had it setting up like this, so it was in the vise, and had the heat gun on the metal using the medium heat setting with it up pretty close. And just kept tugging on this lightly to pull it away, got it off, cleaned up the back a bit, and it's ready to go back on again. In the meantime, I also noticed that there's next to nothing out here holding the thing on. You know, it's pretty well all the stuff up at this end. So anyway, it's still got a bit of strength down in here. So I think we're going to be okay, but yeah, it's very, very strange in terms of such a thin mounting to hold something so significant. But I think we're going to be okay. So I'm going to glue that on there, but I'm also going to put in some pine wood, and providing the strength in here is going to help to keep it from twisting back and forth a bit. You know, it's largely what's happening right here at the bottom for that twisting, but nonetheless that will help having that stuff behind it and make it a little bit more secure as far as it's staying in there. The actual join on the arm seems to be fine. I notice I haven't put a screw in it yet, so we'll do that in due course. But that is not allowing movement as far as that part of it goes. The movement was basically the mounts both on these tabs here, plus the rubber on there, and the screws not being as tight as they should have been. I've got my brass plate, which has been lightened up, glued with epoxy back onto the balsa there. And that is all nice and solid now. I was going to put some wood back here for helping to support that, but I got thinking that a better approach is actually to use double stick tape. Let's see, this is going to go like that. Yeah. So it's going to go like that. So if I put double stick tape between the servo and that plate, I think there'll be enough room for it. And that will really help make that much more solid and lighter weight than putting the stuff back there, and probably more secure as well. So let's give that a try, see what we can find. So I've got a couple of strips of foam double stick tape on there. This particular stuff, it's no easy feat getting the backing off of it. There we go. That's it. So we've got our foam tape underneath the servo. We've got it bolted on to the brass. And this is now ready to get installed. That should all be good. I'm going to get our cable back through there. I'm going to get this to where it doesn't hook on the hole going through. And go through straight. Okay. Okay, I got that. That's pretty well it. Okay. Just snug, that's balsa that we're working with there. We're very close in terms of clearance of this rod to the balsa on the side there, but we'll keep an eye on that. Okay, let's see what it's looking like now in terms of slop. So we hook up a battery to our servo tester, hold the button in to get in the test mode. Let's put it into the middle position, 1500. That's going to push forward, and I think that'll all be fine. Okay, now we get into our normal position here. So it goes down, got a little bit extra travel there. Goes up and got a little bit extra travel there. Certainly more solid than what it was in terms of flopping around. But we still have this thing kicking back there. So I think I would like to put that thing on here that we were talking about to extend this down to make that lock in place with this having just a little bit of tension on it. Yeah, it'll be interesting how sturdy that is when it gets beat around. And of course, like this, it would work, but that position would probably be better. So if we're to do it with existing thing, I think that's what we'd do, is we'd have something like that be the if we have that to where when this, of course this thing can go back as well. And that's putting a little bit too much tension on it. Yeah, something like that right there works pretty good actually. Okay. What I might do is I'll leave this one like it is, and then working on the second one I will try a slightly different brace down here. And then I'll compare the two as to what I think. But we've got it able to push back if it hits kind of hard, and it's able to push down. So that gets us the suspension that I really want to have. There's a little bit of flexibility back and forth, that's not a problem, as long as it's holding the plane up. In finalizing this side, I've added some plastic bushings in here. These are just prop adapters that you get with a new propeller. So you pick the appropriate sizes. There's one on each side, and that eliminates any rubbing on the rods here on the side. I've adjusted the length of these rods to get the axle nice and perpendicular to the axis of the airplane. I've adjusted the length of the push rod down here such that when it's in the down position, it's straight like so. Then it goes down all the way. We've increased the clearance here a little bit. Having this part of it out with that part of it there, that helps to make sure that the outside bit can't get over and hook on to that. So that works out real well. So all the way one way, and that is clear with the adjustment I made to the length of the rod here, and all the way down, and we are all set. So that's all of that, and I'll now do it for the other one with also the extra little bits down here. Well, thank you again for watching. It's great to have you aboard, and of course when I say aboard, well, that means you need to subscribe. As a subscriber, these videos will be handy. You'll be able to find the next in the series, go back and look at the earlier ones, and of course you'll see a link over here to another recent video. So I'm RC Jim signing off. You have a great day. Enjoy your flying and your building.